All right. Now, this is a sample, and this sample has come from where? This sample has come from a larger population, which is women in this 37,000 who are numbered 3960. All right. And this has come from all women in that area, which is 18 to 35, attending general practice. So what we intend to do, when we find the result as 2.6%, does this mean that this is the same inference or this is the same result which also hold true for a larger population, which is study population, which is this one? Or can we extrapolate this to a larger population of 37,000? Now let me make it clear. I told you in the last class, we are drawing statistical inference from little to large. That is the idea. So theoretically, what we could do is we could draw another sample of women from 18 to 35 years, numbering 765. But can we get our estimate as 2.6%? It might not be. It may be 2.7. It may be 2.8. It may be 3, depending upon how representative is the sample of the women who are coming to general practice. So this is how the inferences are made. That means we include from a very small sample to a larger population of interest. And we were talking last time. We talked about that in reality we do not do it. We draw a confidence around this 2.6%, like we draw 95% confidence around 2.6%. It may turn out to be 1.1 to 3.5. That means what? That means we are confident that if we keep on drawing samples from this population, 95 out of 100 times we'll get a value, the estimate between 1.1 to 3.5. Agreed? No, 1 in 5 times we may estimate lower or we may estimate it higher. This is what is called as a sampling error. And this is the whole crux of the problem, of the issue. What we want to do is to quantify this particular phenomena or the chance and say upfront, as I said earlier, that it is investigator, he would say, I will accept going wrong in 1 in 20 times or 5 out of 100 times. Let's see the next one. You could see this slide. It presents the same kind of data. You have a larger population and you pick up a very small, the rectangle you could see. You study this and you try to draw conclusions about the population of interest, that is whole of the population. Now, as I said, the statistical tests in CI allow us to take this imprecision into account. And that is where we say that the statistical tests, which are based on probability, they quantify the uncertainty. Remember, let me give you one warning. If you have a poor design, if you have conceived your study poorly, even the most sophisticated tests cannot correct the poor design. So statistics is one thing, but the epidemiological design of the study is something which you have to ensure. Let's look at few case scenarios. The first one is this. This case scenario is, in a 9-year follow-up study of cytological screening, histories for 437 women with borderline cytological changes in 1981 was compared with that of an age-matched sample of 437 women with normal cytology. Now, you could see this is a kind of study design which I'm sure one of my colleagues is going to take up next time. Now, what they do, they assemble 2 groups. One is 437 women with borderline cytological changes, and they age match it with 437 women with normal cytology. They follow it over a period of time and see how many of them develop high-grade dyskaryosis. Now, this is a design which is called as a prospective study or a cohort study, a prospective cohort study, or a forward-looking study. Now, what they see is, in one group, 22.4%, that is 98 out of 437, progress to high-grade dyskaryosis compared with 0.7% in the control. That is 98 out of 437 and 3 out of 437. Now, the question is, do we really need to apply some statistical tests? No, because we are going to look at event here. So there are some statistical techniques which are survival techniques, which is called Kaplan-Meier and something like that. Do we really need test of significance in such setting? That's case scenario one. Remember, it is 22.4% against 0.7%. That's one scenario. Another case scenario. You have considered the following results from an influenza vaccination trial carried out during an epidemic. 20 out of 240 persons were given quadrivalent vaccine, contracted influenza compared to 80 out of 240 given a placebo. So again, you are comparing two proportions or percentages. In one group, it is 8.3%, and in another group, it is 33.3%. Now, is there any convincing evidence that the vaccine is effective? That's the question. This I showed you last time also. This is a tuberculosis trial, and it was the famous streptomycin trial of Medical Research Council, 1945. There were two groups. One was streptomycin, other one was given bed rest, the treatment of which was prevalent at that point of time. In streptomycin, there was 55. In bed rest group, there were 52. And we looked at the deaths. In streptomycin group, 4 people died, whereas in bed rest group, 14 died. The difference is 7.3 versus 25.9, right? Again, the question is this a large enough difference to be seen by way of chance? Can we quantify this? And can we quantify this uncertainty by way of applying a chi-square test? Another example, you could have, no, all the three examples which I presented were difference in proportions, percentages. But you could have an example where a team of researchers would look for something which is the levels of vitamin E and C with and without lung cancer. And you could see in vitamin E, you have 6.03 as the mean, 0.35 as the standard deviation, and in non-cases, 6.30 as mean and 0.05 as the standard deviation. Now, we have a difference in vitamin E, which is 0.27 milligram. Now, is this a large enough difference? And is this difference clinically relevant or not? And whether we could apply any test of significance to see whether there is a statistical significance or not. Okay. Now, I keep referring to the Austin Bradford Hill. His viewpoint was this. He said, test of significance fine, but any epidemiologist, any investigator should apply common sense in the analysis of epidemiological data. And also he said that a medical research could benefit from a prudent diet of simple data displays and careful thought about bias and confounding. So if something throws up a very highly statistically significant difference, you should not accept it like this, because there are other, apart from the chance, there are other things which could throw up that difference or distort that difference or association. And two of the very important things which any epidemiologist or any investigator has to encounter is one is bias, which is a systematic deviation from truth, and confounder, which you could say are defined as, and a third factor, an extraneous factor, proving something when it is not there, or masking something when it is there. So this was A.V. Hill's viewpoint, and it's very pertinent. We should not be mechanical in applying all kind of, because you'll see later in my presentation, you'll have a large number of statistical software available where you could get any amount of output. But that output should be accepted or discarded in a way which A.V. Hill says you should apply your common sense, the clinical sense, in either accepting that or discarding that particular information. Now, he said very beautifully, and it needs to be read. He says, there are innumerable circumstances, situations, in which the test of significance are totally unnecessary, because the difference is so obvious, because the difference is negligible, or because whether it is formally significant or not, it is too small to be of any practical importance. What is worse, the glitter of tea table diverts from the inadequacy of the fear. So again, he keeps repeating the same thing, that it is you who could make a very preliminary impression that you don't need to apply a test of significance. It's so obvious. Or it is such a small difference in the particular setting that even if it is turned to be statistically highly significant, it doesn't matter. So again, you will have to choose the clinician's choice in a particular setup or in a situation. Okay, now which statistical test? I think somebody is going to go, but I'll tell you something, because you can't apply tests like this, because there's a basic background where you need to know. One of the important things is nature of variable. Now, when we talk about nature of variable, we have two particular distinctions. One is a quantitative variable and one is qualitative. It's very confusing to many people, but we deal with all kinds of variables like this. Let me tell you and give you very important input. Anything which you could count is a qualitative variable, qualitative discrete. Anything which you measure is a quantitative variable. So the nature of variable actually tells us which kind of statistical test is to be applied. The scale of measurement. I don't know whether Dr. Bhavna has talked about. There is a very crude way of measurement, and there's a very, very refined way, starting from nominal scale to a ratio scale. Nominal is just name. From nominal, it comes ordinal, where something can be ordered or ranked. From there comes something which can be measured. And then the final ratio, where there's a true 0 point. So I think you would have been given. So you need to understand, is it nominal, is it ordinal, or interval or ratio scale? And then, of course, I'm told that you have been taught about the normal distribution. There has to be some assumption. There are basically two kind of branch, big distinctions of test, which is parametric and non-parametric. The t-test which I'm going to talk about today is one of the most commonly used parametric tests, because उसमें क्या होता है कि जो वेरिएबल जो आप स्टडी कर रहे हो, you have to assume or you have to show that that is normally distributed. If it is not normally distributed, then you will have to go for a battery of tests which are called as non-parametric tests. I think we could, if you have some question later on, I can make it more clear. But there are some assumptions which are to be met before you decide which statistical test is going to be appropriate in particular setting. Okay, so what are the tests which we are going to talk about? You could have, we are going to talk about t-test and chi-square test. T-test again could be just one sample, and this one sample is actually compared with some unknown population mean. Then you could have a unpaired t-test. Unpaired t-test means where there are two groups of people. You have made observation on those two groups of people and they are independent. And you want to see whether between these groups, there is a difference. And if there is a difference, what is the magnitude of difference? And is this difference statistically significant? So we apply unpaired t-test. And then you could have a situation where you are the same people, you measure something today, you measure something after 3 months and see whether there is a difference between pre and post. So you have same number of same people who are measured twice. Again, you want to see whether there is a difference in pre and post. Is it a difference which is positive or negative? The size of the difference and what is the role of chance. And then you calculate what is t statistic and see whether it is beyond that level of significance. If your statistic, t statistic or chi-square test statistic is bigger than the theoretical value, you have seen that normal distribution where you put a line. If it is beyond that, you reject the null hypothesis. If it is less than that, if it's towards the center, then you accept the null hypothesis, say there is no difference. So I'm going to talk about chi-square, I'm going to talk about t-test, and I'll give you some idea about some little bit of calculations of chi-square. I'll not do that for t-test because that will take more time, but I'll show you what actually goes into the calculation of t before we go on to do some hands-on. So before we talk about that, one important aspect is to be understood, and that is called as degree of freedom. So what is this degree of freedom which is referred to as F? It is a number of independent observation and data group. So let me give you an idea. If you have 5 observations, and let's say they are 1, 2, 3, 4, 5. 1 and 2, 3, 3, 6, 4, 10, and 5, 15. It becomes 15 total. And if you calculate its mean, it comes to be 3. 15 divided by 5 is 3. Now, if you know the mean, and if you know the 4 values, you could always find the 5th value. So what does it actually mean is that you have, in a set of data, you have n minus 1 choices, degree of freedom. For example, there's a hockey team where the captain also wants to play. So if captain wants to play, the total number of 11 places. So he also wants to play who only has 10 degree of freedom. He could only choose 10 people. And this degree of freedom is required to be understood because we are going to deal with all the distribution, T distribution, chi-square, which are based upon the degree of freedom. Let me give you upfront a very important input. That is, as soon as the sample size increases, these particularly T distribution, that becomes almost as if it is a normal distribution. So there is no difference between the Z value, which is from the normal distribution, and the T value. And they say some books write that the sample size is, if it is less than 30, you apply the T test. If it is more than 30, you apply the Z test. Some books say, no, it is 50. But more the number, there is a equivalence between what statistic you will get from T test and Z test. And then I'm going to talk about 2x2 contingency R by C table. I'll actually demonstrate and how it is related to degree of freedom. Okay, we just recap. How do we do the steps of doing significance test? First is we state the null hypothesis, which is hypothesis of no difference. We say upfront that there is no difference or there is no association, or the difference between the two groups is 0. And then we also explain what is the alternative. We say, no, there is a difference where A is better than B or B is better than A, because we are going to apply a two-tailed test. We are considering both the tails, the negative as well as the positive. Then what we do? We mount a study, we collect the data, we calculate the P, and we calculate the test statistic and see it within the comparison of P, and see if your calculated statistic is bigger, then you reject the null hypothesis. If it is low, then you accept the null hypothesis. And as I told you in the last class, always you make two kind of right decisions and you make two kind of wrong decisions. The first one, which is rejecting the null hypothesis when it's true, it's alpha error, and accepting the null hypothesis when it's false is a beta error. And I said that both should be kept to minimum, because we want a right kind of decision to be made. All right? But you state it upfront that I would only tolerate an error of 0.05 or 0.01. And that is where your comparison with test statistic and the p-value would, and you will generate a conclusion. Okay. Let me tell you a very basic thing. If everything was the same, if there was no variability, then there should have been no statistics. Statistics comes because there is a variability. And this variability leads to some differences by chance. And whatever test of significance we do, we actually quantify the amount of chance. If you look at this particular slide, you find t-test. So on the numerator is what? The difference between group 1 and group 2. That is x1 minus x2 bar. When we say x bar, bar is when it is on the top of the, you have a horizontal line. So it is a difference. You could imagine the bigger the difference between the two groups, the numerator becomes large. You have more chances of getting a significant difference. And down below is what? Is your standard error or standard deviation. And when we are dealing with two groups, we have to find a way to combine these two standard deviation into one, which is called a pooled standard deviation. All right? I don't think you need to go. You have this. If you want to understand this, you could go through, but there is no need, because I'm going to do it with the help of some softwares. Now, you have N1 plus N2 minus 2. This is the degree of freedom, because you have two groups. So you add up the sample size of 1 plus the sample size of 2 minus 2. So they are not, as I said, the number of independent observation in one group would be N minus 1. But since you are dealing with 2, so what you have to do is N1 plus N2 minus 2 would be the degree of freedom for t-test. T-test, which is a independent t-test, means that there are two different groups, and these two different groups could have two different sample sizes. Similarly, is another example with where I have given some mean, and at this I'm going to demonstrate with the help of, we have some software you could do with mean and standard deviation, and some software you have to enter the actual values. It's the same thing which I have shown on the last slide. Then you have a pair t-test. We said pre and post. So that means you'll have a mean difference, which could be positive or negative. Pre could be more than post, or post could be more than pre. So you could have either positive difference or negative difference. So that is defined as, it is something like D. And again, it is divided by standard deviation over N, which is standard error. And then this is the formula for T. The numerator is the difference between the two, pre and post, and it's divided by your standard deviation. And here, the degree of freedom, because it's only one group, the same number of people. So if you are studying 90 people, then it means 90 minus 1. I said the number of independent observations in a set of data. Now I show you before we start making decision, this is something which you have seen. Just a minute. This is the Z table. And we said that we'll stop P here. We'll put P here. And if anything is, any test statistic is here, it comes here, we reject the null hypothesis. If the test statistic is here, we accept the null hypothesis. Now let us look at, on top of it, you would say, on top of it, you say this is a Z normal distribution, and you have, when you were told normal distribution, you were given that the mean, mode, and median lies at the same place. This. And you have something like 1 standard deviation on both sides. Then you have 2 standard deviation. And then you have 3 standard deviation. 2 standard deviation is actually taken as 1.96 and 3 standard deviation is taken as 2.58. So let us look at 1.96. 1.96 comes at this place, which is the 2. So if you look at 1.96 is here. And this is 0.06. 1.9 plus 0.06. That becomes 1.96. And you look at the value here. You have a value which is 9750. 9750, 1 minus 9750 would become how much? 0.250. 0.250, right, on one side. So because we are using two-tailed test, so we would reject here also, and we will reject here also. So this is how a Z table. So if you have your sample, which is larger than 30 or larger than 50, and you are looking for differences, then you're going to apply Z test. You can apply T test also, but it would give you the same test statistic. We look at the next one. This is the two-tailed T test, and it also gives you value at various levels of significance. For example, it is 10%. We are bothered about the conventional, which is 5%, 0.05. And depending upon the degree of freedom, you'll have some values. Now, these are the values which are which you have to compare with your test statistic. So if you have a value, let's say you have total 16 as sample size, तो n-1 कितना आ जाएगा? 15. अगर आपके दो ग्रुप हैं तो आपका आ जाएगा, अगर 16-16 दोनों में है तो 32 हो जाएंगे. 32 में से 2 निकालोगे तो 30 हो जाएगा डिग्री ऑफ फ्रीडम. So if you look at the degree of freedom here it will be 30. Just a minute. It will be 30, and you look at the value here. You look at the value in front of 0.05, which is 2.04. So depending upon if you have got a value which is more than 2.04, you reject the null hypothesis. Otherwise, you will accept the null hypothesis. Similarly, you have a chi-square distribution. Every distribution is different. So you have a degree of freedom, and if you have a degree of freedom which is 1, which I'm going to demonstrate now, then you'll have a value which is 3.84. So if your calculated value of chi-square is more than 384, then you reject the null hypothesis at 0.05 or 5% level. If it is degree of freedom is 2, then you are going to look at the value which is 5.99. Now, let me explain it with the help of some statistical software. I hope you got the basic idea. Is there any question? Is there any question?
The chat box is open for everyone. If there are any questions, you can type down your questions. Or you can raise your hand.
It's important before I go ahead. Okay, you keep your question, no problem. So let us first look at apply these tests in MS Excel. Let's say I have. Can you see my? आपको
So your
Excel,
PPT is visible. PPT is
आपको
visible.
ये Excel वाला नहीं है? Excel नहीं आ रहा? एक मिनट रुको,
No, sir. No.
रुको रुको, just wait.
Yes, sir.
Just wait. Just wait. अभी दिख रहा है? Can you see this?
Yes, sir.
अभी दिख रहा है ना?
Yes, sir. Yes, sir.
Okay. Let's say we apply a test of significance, which is we have 5 sample size in 2 groups, right? And we just input some information here. So let's say you have measured something as urea in 2 groups of 5 each. So you have value like 23, 35, 56, 54, 23. And in another group, you have values like 45, 78, 54, 23, 21, right? So as I demonstrated earlier, the first thing you have to do is to calculate its mean, right? And you have to find what is the difference between mean of A and B. And then you will apply a t-test to see how big is the difference in the mean, and then to decide whether this is due to a chance difference or the difference is due to the other some other factor, right? So here what we do is look at, you have a function fx key here. You see that? You have a fx key here. And you said it would be on this menu, you will have a statistical test. In statistical, what you want to do is you want to apply t-test. So we go to t-test, and t-test is here. Here it is t-test. So you have array 1 and array 2. So what you have to do is you have to select array 1 and input it here. Then you'll have to select array 2 and put it here. Then it is going to ask you one more question. It will ask you whether you want, you put a cursor here, and down below there appears a command. It says specify the number of distribution tails to return. So put 1 if you want one tail distribution, and put 2 if you want 2 tail distribution, right? I said conventionally we go for 2 tails because we want to see, we do not often see whether the difference is going to be positive or negative. Only in some circumstances we say that the difference is positive or negative, and then we choose the one tail test. Remember, 2 tail test would have a lower confidence and 1 tail would have a higher confidence. So I'll put it input 2. Then it say what kind of, if you the last type, and again a command appears, it says what is the kind of test you are going to use. Say t-test paired 1, if you are going to put up the unpaired test, put 2, and they say, is there equal variance? Variance is what? Variance is basically square of standard deviation. So अगर आपके दोनों सैंपल की वेरिएशन जो स्टैंडर्ड डिविएशन बहुत अलग अलग है, तो फिर आप 2 वाली ऑप्शन नहीं डालोगे, आप 3 वाली ऑप्शन डालोगे, राइट? So let us assume that it has the same variation. So we put 2. Once you put it, you get a result which is 0.65. Now this is the probability associated with student t-test. So what is your right now, if you look at it, डिग्री ऑफ फ्रीडम कितना है आपका इसमें? अगर आपको टी टेबल देखना होगा तो डिग्री ऑफ फ्रीडम क्या है? 5 + 5 - 2, ठीक है? You have 5 in first group, 5 in second group, n1 + n2 - 2. और अगर आप 8 के नीचे देखोगे 0.5 की जो वैल्यू होगी, 0.05 की, द टेस्ट स्टैटिस्टिक इज 2.30, ठीक है? तो 2.30 आपकी वैल्यू कितनी आई है? 0.65. तो 0.65 इज लेस देन 2.30. जो आपका लाइन हैज टू बी ड्रॉन समवेयर. तो लेस है तो क्या करोगे आप? यू विल एक्सेप्ट द null hypothesis, right? Now we can apply the same test as we have already input information from group A, then we have already put information from group B, and we have said it, we are going to do a two-tail test, but we will do a pair test. Again, the pair test, the value is 0.656. Again, it is not significant. Now, the problem here is that it returns P, but it doesn't give you the value of T. And that value of T you could get from some other software. I'll show you one, which is very interesting software, and that is, let me show it to you. Where is it? Yeah. Just wait. I'll have to close the other one. Just wait. Where is it? Sure. Wait. आपको दिख रहा है ये वाला SPSS का है? Can you see this?
Yes, sir.
Okay. So this is another, and here I have listed some 2 variables, which are 15 each, right? Now, if I have to apply a t-test here, I'll have to enter the data very differently. So what I'll do is, I'll list the data, and I'll put it here, and I'll group it. One, and two. It has to be put like this. Sorry. It has to be put like this. Okay. Now you go to analyze. You go see there is a menu which is compare means. So I go here and it is independent test. And then a window appears. So which test variable you are interested in? You are interested in 1 and 2? No, 2 and 3. This one is the one. So 2 and 3. Put it here. Sorry. 1 has to come back. Grouping variable is 1. Grouping variable is, sorry. You'll have to put it here. Grouping variable is 3. And you have to define group 1 is 1. I'll show you what output it gives us. Okay. Now look at this. You have large number of values come here. So if you look
So
at
the output is not visible.
नहीं मिल रही है आपकी आउटपुट नहीं मिल रही है
No, sir.
आउटपुट
सर रीशेयर करनी पड़ेगी स्क्रीन.
I think you will not be. I'll tell you what it gives you, right?
Okay.
Let me stop here and again share. Where is it? Yeah. अभी दिख रही है? No.
Yes, sir. अब visible है.
Okay. So what you see is variable 1 and 2, right? And both have 15 on the upper table, right? You have 15 in one group, 15 in two group. Look at the mean. It is 16.5 and 9.6. So there is a difference of 6. And this you have to decide whether this is a significant difference or not. Then you have a standard deviation also, 8.54 and 4.32. Now I said that if the standard deviation is not equal, then you'll have to go for different test. So it has applied that test and it's a Levin test for equality of variances. Variances is the, standard deviation. तो स्क्वायर कर दो आपको वेरिएंस मिल जाएगी. तो आपको ये क्या दिख रही है? सिग्निफिकेंस टी की वैल्यू दिख रही है 2.80. वेयर एज आपकी वैल्यू कितनी होनी चाहिए थी? तो अगर टेबल पे देखोगे, यहाँ पे देखोगे तो ये वैल्यू आपकी 0.03 पे सिग्निफिकेंट आ रही है. तो व्हाट वुड यू डू? 0.03 is less than 0.05. Agree? What you will do? It is significant. You could see two-tailed is 0.009. Not this one. This is the significance part. You look at 1, 2, 3, 4, 5, fifth column. It is 0.009. That means it is highly significant. That also means that the difference of this magnitude could happen by chance only once 9 in 1000 times. So that's a very, very significant difference. You got my point? Similarly, if you go back to your data, you could apply a test which is called as compare means, and you have a paired sample. And paired sample, you will have to apply. I'll have to change the data and remove this. And now what I'll do is pair. I'll have variable 1 and 2 because the entry is little different. And if I press OK, you get a test. It is a paired sample now. Again, the mean is 9.6 and 16.53. Standard deviation is this much. And look at what the result is. Let me see. It is here it is. The difference in mean is 6.93 and it is 0.17 significance. So both the differences are significant on unpaired test and paired test. Remember, the only difference here is that in unpaired you had independent sample of 15 each, and on the paired you will have the same people who are measured twice. I hope it is clear. So that is how you apply what is called as the t-test on SPSS. I'll show you one more, which you could do yourself also. Let me give it to, yeah. Can you see the screen?
Yes, sir.
Okay, now you have a it's open source epidemiological software. It's called as OpenEpi. आप कहीं भी खोल सकते हो। और एक लेफ्ट साइड पे जो मेरे स्क्रीन पे आपके वो एक मेन्यू है, उस मेन्यू में बहुत सारी चीजें लिस्टेड हैं, राइट। अगर हमने टी टेस्ट करना है तो अगर आप जाओगे नीचे नीचे यहाँ पे आ जाओगे, ये आ जाएगा आपका टी टेस्ट, राइट। बड़ा आराम से निकल जाता है इससे। लेकिन इसके लिए क्या चाहिए, इट डजंट टेक अप द एक्चुअल वैल्यूज, सो इट नीड्स वैल्यूज विच आर mean and standard deviation. For example, it is already, you said confidence interval is 95%. तो आप पहले डिफाइन करोगे कि आपको लेवल ऑफ कॉन्फिडेंस कितना चाहिए। तो जनरली हम 95 को प्रेजेंट करते हैं 0.05, ठीक है। और आपने टेस्ट कौन सा लगाना है, टू साइडेड। मान लो एक ग्रुप में सैंपल साइज 7 है और दूसरे ग्रुप में सैंपल साइज 18 है। एक का मीन 11.57 है, दूसरे का मीन 7.44 है। एक का स्टैंडर्ड डिवीएशन 8.81 है और एक का 3.6 है। मान लो आपके पास SPSS नहीं है, तो आप क्या करोगे, यू कुड गो ऑन टू द एक्सेल, यू कुड कैलकुलेट योर मीन एंड स्टैंडर्ड डिवीएशन, इनपुट इट हियर। करना आपको कुछ नहीं है, आपने अपना सैंपल साइज डालना है, मीन डालना है, स्टैंडर्ड डिवीएशन डालना है, ग्रुप 2 का डालना है और कैलकुलेट करना है। कैलकुलेट करने पे आपके विंडो अपेयर हो जाएगी विच विल गिव यू सम रिजल्ट। और रिजल्ट आपको क्या दे रही है, टी टेस्ट का दे रही है। द वैल्यू जिसमें ये अज्यूम किया है कि दोनों की स्टैंडर्ड डिवीएशन एक जैसी है, दैट इज 1.68, और आपको पी वैल्यू देगी विच इज 0.10। नो 0.10 और 0.05, तो ये किस तरह पड़ती है, ये सेंटर की तरह पड़ती है, ठीक है ना। तो आप क्या करोगे, यू विल एक्सेप्ट द नल हाइपोथेसिस। one good thing is that it also gives you the confidence interval, lower limit and upper limit। और जब भी लोअर लिमिट और अपर लिमिट के बीच में 1 आता है, 1 इज नो डिफरेंस। तो आप देख रहे हो 0.94 माइनस से लेके 9.2 है, तो यू कुड अज्यूम दैट द डिफरेंसेस आर गोइंग टू बी नॉट सिग्निफिकेंट। So you could do t-test on Excel where you would find the p-value but not the t-statistic. You could do if you have access to SPSS. अगर नहीं है तो आप क्या कर सकते हो, मीन ऑफ स्टैंडर्ड डिवीएशन वहां पे निकाल के then you could go on to input it in a very open source software which is OpenEpi, and then you could do it yourself, right? Now, what I'll demonstrate here is a t-test, is a chi-square test। और chi-square टेस्ट के लिए आपको क्या चाहिए, आपको 2x2 टेबल चाहिए। तो अब 2x2 टेबल जब आपका आएगा, 2x2 टेबल इज व्हाट, 2x2 टेबल इज a table which has 2 rows and 2 columns. Actually it has 3 rows and 3 columns, but it is called, वो मार्जिन में है। तो हम क्या करेंगे, हम बोलेंगे डालेंगे इसमें वैल्यूज। एंड रिमेंबर अभी थोड़ी देर पहले हमने एक डिस्कस किया था डेटा, जिसमें बोला था 20 out of 240 and 40 out of 240, right? Let's say we have a value where in one group 20 out of 240 recover and in another group 40 out of 240 recover। So हमने क्या करना है, हमने एक टी टेस्ट, chi-square टेस्ट लगाना। तो chi-square टेस्ट कैसे लगेगा, chi-square के लिए आपको पता है, मैं अभी थोड़ा डेमोन्स्ट्रेट भी करूंगा। chi-square टेस्ट के लिए आपको डिग्री ऑफ फ्रीडम चाहिए। तो 2x2 टेबल में डिग्री ऑफ फ्रीडम क्या होती है, उसको बोलते हैं डिग्री ऑफ फ्रीडम इज गिवन बाई r-1 and c-1 multiplied by c-1। r-1 is row -1 and c is column -1। तो 2 रो है और 2 कॉलम है, 2 - 1 और 2 - 1, तो 1 डिग्री ऑफ फ्रीडम आपकी होगी। ठीक है, तो जो हमने रिजल्ट देखने हैं वो टी टेबल में 1 डिग्री ऑफ फ्रीडम, तो जो मैंने आपको टेबल दिखाया था 1 डिग्री ऑफ फ्रीडम पे जो वैल्यू रिजेक्ट करने के लिए या एक्सेप्ट करने के लिए चाहिए वो 3.84 है। रिमेंबर दैट एंड आई इनपुट द इंफॉर्मेशन। तो पहला क्या था, पहली थी 20 रिकवर, तो इसका मतलब 220 डू नॉट रिकवर। ठीक है, तो ये 240 हो गए। दूसरे में 40 रिकवर कर रहे हैं और 200 रिकवर नहीं कर रहे हैं, तो ये हो जाएगा 240, टोटल हो गए 480। ठीक है, अब कुछ नहीं करना आपने, आपने बोलना है कैलकुलेट। अब आपके पास कुछ वैल्यूज आ जाएंगी, यू सी दैट। तो टॉप पे वैल्यू, ऊपर तो वही वाला टेबल है बना हुआ, उसके नीचे वैल्यू जो आपकी काई स्क्वायर की आई है विच इज 7.619 and p value is 0.005. 7.61 is higher than the value of 3.84. So you would reject the null hypothesis and say that there is a difference. Now I'll demonstrate all these things on another. मैं नोट पैड पे आपको करता हूँ, इसको मैं स्टॉप करता हूँ and I'll open just a minute. Just a minute, I'll get my notepad. Okay. Okay, can you see this now? आपको
Yes,
दिख रहा
sir.
है? Okay, fine.
Yes, sir.
So what we do is, let me set it right. Okay. So we have a data. हमने बोला था हमारे पास स्ट्रेप्टोमाइसिन का डेटा है। Just a minute. Just a minute. No. Okay. Yeah. So we have data. We looked at. We had in one group, streptomycin group. We had how many people? We had 55, right? In placebo group, we had 50 and 52, right? So let us make a 2 by 2 table here. And I said 2 by 2 table is not 2 by 2, it's actually, sorry. It's actually 2 by, so we do here and we say here and we write streptomycin and we say placebo and we say died and we say survived. No, the best way to fill up is to first fill up the marginal total. So how many we have in streptomycin group? 55. How many we have in the placebo group? 52. So that becomes 107, right? How many died? 4. And this becomes 51. How many died here? Sorry, 14. And this becomes 38. And this becomes 18. And this becomes 89. So we completed this. So this is the data which we have, right? Here we had 4 versus 14. 4 died among 55 and in placebo group 14 died, right? So this is how you complete your table. Now doing calculations with this data would be little difficult because it would come into decimal points. So what I'll do is I'll change the data to the same which we have done with the help of OpenAPI. So here that was 20 out of 240 versus 40 out of 240. Agreed? And we put it here. We put it here. Okay, I just rub it off and make a new table. What we do here is start table here. And as I said, we put a 240 here, 240 here, and total becomes 480. Okay, 20, you have 200, 20, you have 40, you have 200, you have 60, you have 420. Now this is, all right? Now let me tell you, when we said that whenever we planned something, we said that there is no difference in the null hypothesis was that there is no difference in the mortality rate or efficacy rate or whatever it is. So what we have observed is 20 out of 240 and 40 out of 240. But we upfront started with a null hypothesis that there is no difference between the death rates, right? Alternate hypothesis, yes, there is a difference, right? Now, imagine if there was no difference, we have observed 20 out of 240 and 40 out of 240. If there was, these two groups were independent, they had no association or they had no relatedness, we would have expected value on the basis of null hypothesis. So, in calculation of chi-square, what we actually do is we calculate the expected value. अब expected value कैसे निकालते हैं? Expected value मान लो हमने निकाल ली है इसकी, हमने 20 ऑब्जर्व की है, तो अगर कोई डिफरेंस नहीं होता या रिलेटेडनेस नहीं होती या डेटा इंडिपेंडेंट होता, तो कितनी वैल्यू यहाँ आनी चाहिए, हाउ मेनी डेथ्स वी शुड हैव ऑब्जर्व, उसका निकालने का एक फॉर्मूला है विच इज कॉल्ड एज रो टोटल इनटू कॉलम टोटल डिवाइडेड बाय ग्रैंड टोटल. तो अगर हमने सेल ए की, दिस इज सेल ए, अगर हमने इसकी एक्सपेक्टेड वैल्यू निकाल ली तो क्या होगा, रो टोटल कितना होगा, हाउ मच इट वुड बी, रो टोटल कितना है ए का, रो कौन सी होती है, हॉरिजॉन्टल वर्टिकल,
हॉरिजॉन्टल.
हॉरिजॉन्टल. तो फिर पहले क्या करेंगे, हम बोलेंगे रो टोटल क्या हो गया, ये वाला, ठीक है, 60 मल्टीप्लाइड बाई ये वाला 240, ठीक है, और डिवाइडेड बाई ग्रैंड टोटल कितना है 480, राइट. ये क्या हो गया 2, ये क्या हो गया 30, ठीक है जी, एग्रीड. नो, इफ देयर वाज नो रिलेटेडनेस, what should we have examined, we should have observed if null hypothesis was true as a value which is 30. ठीक है. अब आपको मैंने क्या बोला था, अब नेक्स्ट कंसेप्ट जो है वो क्या है, नेक्स्ट कंसेप्ट है डिग्री ऑफ फ्रीडम का. अब आपको सारी वैल्यू कैलकुलेट करने की जरूरत नहीं है. अब मैंने बोला अगर आपकी मार्जिनल वैल्यूज आपको पता है, ठीक है, तो डिग्री ऑफ फ्रीडम आपका क्या है, 2/2 टेबल में आई सेड R-1 C-1. तो रो कितनी है, 2 है, -1, और कॉलम कितने 2 है, -1, तो कितना हो गया 1, ठीक है. अब कहता है ये कि अगर आपके पास मार्जिनल टोटल आपको पता है, ठीक है, ये वाले, तो फिर आपको एक ही वैल्यू कैलकुलेट करनी. जब आपको 30 पता चल गया तो बाकी वैल्यू अपने आप आ जाएगी. तो बाकी क्या आएगी, ये 30 240 से निकली, जहां कितना आ जाएगा 210, ये 30 है, तो ये 30 है तो ये भी 30 हो जाएगी। ठीक है, अगर ये 30 है, ये 420 है तो ये हो जाएगी 390। ठीक है, ये अब आ जाएंगी एक्सपेक्टेड वैल्यू और ये टोटल का। अब काई स्क्वायर क्या होता है? काई स्क्वायर का हमने फार्मूला लगाना है और बस इसको कैलकुलेट करना है, जो हमने वहां कैलकुलेट किया। काई स्क्वायर कुछ नहीं है, काई स्क्वायर है समेशन, समेशन होता है जो उसके बाद आएगा उसको जमा कर लो। ठीक है, ऑब्जर्व माइनस एक्सपेक्टेड होल स्क्वायर डिवाइडेड बाय एक्सपेक्टेड। ठीक है, ये सारा अंडर रूट में आ जाएगा। तो आपने सारे जितने भी ये बने हुए हैं ना, ये सब सेल को आपने जमा करना है। तो कैसे करेंगे? पहले क्या होगा? 20 ऑब्जर्व थी, -30 था। ठीक है, डिवाइडेड बाई कितना? डिवाइडेड बाई एक्सपेक्टेड 30। तो ये कितना हो जाएगा? ये 100 डिवाइडेड बाई 30। तो एक वैल्यू आपके पास क्या आ गई? 3.33। ठीक है, अब क्या हो गया दूसरा? 40 - 30 डिवाइडेड बाई 40। सेकंड वैल्यू आ जाएगी 40 माइनस जी इसकी वाली, इसकी ऑब्जर्व एक्सपेक्टेड वैल्यू 30 है। 40 - 30 डिवाइडेड बाई 30, 40 सॉरी, डिवाइडेड बाई एक्सपेक्टेड वैल्यू। ये हो जाएगी 30। तो ये भी कितना हो जाएगा? ये प्लस 3.33। तीसरे का क्या होगा? 220 ऑब्जर्व वैल्यू है, एक्सपेक्टेड कितनी है? तो ये भी 30 का डिफरेंस होगा। तो ये होगा, ये भी 30 का डिफरेंस है, तो 30 इंटू 30 कितना हो जाएगा? 900। 900 को डिवाइड करोगे कितना? 220 के साथ, तो ये कितना हो जाएगा? कोई करीब करीब 4 क्या करीब आ जाएगा। और इसमें कितना आएगा? 390 या 420 है, तो 420 - 390 ये भी 30 आ जाएगा। तो ये वाला डिवाइड करेंगे हम 420 के एक्सपेक्टेड 390 के साथ, तो ये कुछ 3.5 आ जाएगा। अब आपका टोटल कितना बना? आई जस्ट लव इट। अब मैं ऊपर से मिटा देता हूँ। अब हम इसको सब सेल्स को जमा करेंगे। कितना हो गया? 3.33 प्लस 3.33 प्लस, रफली मैं कर रहा हूँ, 4 प्लस 3, तो कितना हो गया? 6.5 हो गया। 10 और 3 13, तो 14 के करीब हो गया। अंडर रूट 14 का कितना होता है? कितना होता है? 3 पॉइंट समथिंग, लेट्स से 3.6 आ गया। नो दिस 3.6, और डिग्री ऑफ फ्रीडम कितनी है हमें रिजेक्ट करने के लिए? 3.84। नो दिस इज लेस देन दैट, देयरफॉर वी रिजेक्ट द नल हाइपोथेसिस। अब ये गलत इसलिए हुआ है बिकॉज हमने जो मैनुअल कैलकुलेशन की, बट इट सिंपली इज लाइक दिस। कुछ नहीं करना, आई अगेन गिव यू द स्टेप्स। और स्टेप्स क्या हैं? लेट मी discard this and take another one. Let me again give you the, okay, I'll give you the steps again. You have two proportions. मीन के लिए नहीं इस्तेमाल हो सकता, आपको परसेंटेज डिफरेंस देखना है तो आपको काई स्क्वायर लगाना पड़ेगा। उसके लिए पहले क्या करना है आपने? पहले आपने 2/2 टेबल बनाना है। और 2/2 टेबल बनाने के लिए सबसे पहले क्या है? पहले आपने मार्जिनल टोटल पढ़ने हैं जो आपके पास। उसके बाद यू विल क्रिएट ए 2/2 टेबल एंड लिस्ट योर वैल्यूज। और वो वैल्यूज क्या होगी कि आपके पास? दोज वैल्यूज वुड बी योर ऑब्जर्व वैल्यूज। ठीक है, ऑब्जर्व वैल्यूज के साथ जब आपने देख लिया तो पहली आ गई आपकी ऑब्जर्व डेटा। उसके बाद आपने उसकी निकालनी है एक्सपेक्टेड और एक्सपेक्टेड कैसे निकालेंगे? एक एक सेल के लिए रो टोटल इनटू कॉलम टोटल डिवाइडेड बाय ग्रैंड टोटल। जब जी आपका निकल गया तो आपने फिर काई स्क्वायर का फॉर्मूला लगाना है, विच इज समेशन ऑब्जर्व्ड माइनस एक्सपेक्टेड होल स्क्वायर ओवर एक्सपेक्टेड अंडर। ये वाली वैल्यू अगर आपकी 3.84 से ज्यादा है एट 1 डिग्री ऑफ फ्रीडम, तो आप क्या करोगे? रिजेक्ट करोगे नल हाइपोथेसिस। अगर इससे कम होगी तो आप एक्सेप्ट करोगे, और अगर आप 0.01 पे लोगे तो वो 5.99 होगी। तो अगर आपकी कैलकुलेटेड वैल्यू 5.99 से ऊपर है तो आप रिजेक्ट करोगे नल हाइपोथेसिस, अगर इससे कम है तो आप एक्सेप्ट करोगे। वो जो एक्सेप्ट करोगे वो 3.84 पे सिग्निफिकेंट होगा अगर इससे ज्यादा होगी तो। अगर वैल्यू 3.84 से लेके 5.99 है तो दैट इज एक्सेप्टेबल एट 0.05 but not at 0.01. So this is how you do what is called as the chi-square test. अब एक chi-square टेस्ट की से दो चीजें हो रहा है जो मैं आपको बता दूं, जो मैंने जब कैलकुलेट कर रहा था तो उसमें दो कंडीशंस होती है। अगर कोई आपकी एक्सपेक्टेड वैल्यू किसी सेल में 5 से ज्यादा आती, 5 से कम आती है या 0 आती है, तो आप ना chi-square टेस्ट लगा सकते हैं। आप उसकी जगह उसका वेरिएंट लगाते हैं जिसको बोलते हैं फिशर्स एग्जैक्ट टेस्ट। वो जब आप उस पे ओपन एपिंग पे करोगे वो फिशर की वैल्यू आपको दे देगा। तो फिशर की वैल्यू जो है वो आपको दे देगा, दैट इज द एप्लीकेबल। दो कंडीशन रहती है कि अगर 80% ऑफ द वैल्यूज आर लेस देन 5 और इन वन ऑफ द सेल इफ इट इज 0 देन यू अप्लाई व्हाट इज कॉल्ड एज फिशर। एक और chi-square टेस्ट होता है जिसका मैंने नाम पहले लिखा था, वो chi-square फॉर ट्रेंड है। मान लो आपको पास कोई ऐसा डेटा है जिसमें कोई समथिंग डिफर्स बाई लेट्स से सोशियो इकोनॉमिक स्टेटस, सिवियरिटी ऑफ डिजीज। तो आप सोचते हो कि कोई अगर कोई आपने प्रोपोर्शन ऑफ पीपल देखे हैं वो माइल्ड मॉडरेट और सीवियर में है, और आपको लगता है कि माइल्ड में कम रहती है इसका डेथ रेट और जो सीवियर है उसमें ज्यादा रहता है, तो आप वहां पे सीधा chi-square नहीं लगाते हो, वहां आप chi-square फॉर ट्रेंड लगाते हो जो 1 डिग्री ऑफ फ्रीडम के साथ होता है। ठीक है, और chi-square फॉर ट्रेंड इज ए मोर रोबस्ट टेस्ट देन chi-square टेस्ट। लेकिन वो तभी लगाना है जब आपको लगता है कि कोई चीज जो आउटकम है वो वेरी करती है अकॉर्डिंग टू सम काइंड ऑफ ट्रेंड। अगर आपको ट्रेंड लगता है आपके डेटा में आ रहा है देन यू अप्लाई chi-square फॉर ट्रेंड, अदरवाइज you apply chi-square test. If you are dealing with percentages, you apply t-test if you are dealing with continuous variable. Right? I think with that I have finished my presentation. If you have any question, I'm here to answer them. I'll keep on maybe uh, demonstrating on this notepad. Right? So if you have any question, please. I'm finished from my side. Yeah. Hello.
Thank you all for joining us today. We hope the discussion was fruitful. We are now opening the floor for question answers. Please raise your hand or submit your queries in the WhatsApp group.
Yeah. You'll have to practice a little. I think I have given you enough situations. You can do it in OpenAPI or you could do it manually if you wish to. Because the whole idea is that you should understand what goes into the application of a test. Let me see if there are any queries here. Yeah, you could ask me. I'm here to answer. Yeah. Anyone? Yes.
Guys, the WhatsApp group is open. If you have any queries, you can send your queries in the WhatsApp group, or you can raise your hand. We'll wait for a minute.
Yeah, sure. Yeah, anyone?
So we don't have any queries today. Nobody has asked any questions, so I think we can wrap the session now.
Okay. So what I suggest is that once you are through with this particular course, I would say that if you have some open session, a kind of a session where you ask the questions and I respond to all your questions, I would be happy. Right? Otherwise, if Dr. Bhavna asked me to do one more class, I think I would be ready. And thank you very much for sparing your time and for being with me. These concepts are important. These are good concepts, and you are very young. I think you have started off very early, and I'm very happy that once you practice it a little, because there are so many statistical softwares which are available, you would be able to go beyond this, because what was really important was that you understand the basics of how biostats can be usefully applied in medicine. I think there are a couple of more classes where my colleague is going to talk about the study design. Let me finally give you my comment that you can't study biostats alone. Whenever you study biostats, it has to be with epidemiology. So if you understand the concepts of epidemiology and then try and apply biostats, I think it would be wonderful. And you will realize few years later that what I'm saying has a lot of value. Thank you very much. If you have no questions, then I may stop here. Thank you.
Thank you so much for sharing your advice with us, sir. And thank you so much for giving your time to us.
And I'll share this presentation in WhatsApp. Okay?
Yes, sir. Thank you so much. Thank you, sir. We'll wrap the session now. Sir, you can leave. Yes. Thank you so much, sir.
Thank you. Thank you. Thank you.
Over to you, Ananya.
Okay. So once again, thank you for joining us today, everyone. The feedback form will be shared in the chat box soon, so please don't forget to fill it out.